Hello class. I would like to go over the last two sections of chapter 9. Um, chapter 9, we are finished the course. So for this section 9.4, 9.4, you were learning about the hypothesis test and for one sample, one sample mean. So right here, the whole chapter 9, you learn about inferring population means, right? But for 9.4, you're learning about hypothesis testing for means, for only one mean. Because 9.5, I will teach you how to work with two sample means, not one. So this is only one. So for this section, you will learn about conduct a hypothesis test. To conduct a hypothesis test for a population mean, we are having 4 steps. It's just similar to chapter A. Okay, so right here, you can see first step, you have to hypothesize, which means you have to state out the null hypothesis, which is H naught. What is it, right? And then you have to state out the alternate hypothesis, which is HA. So for that part, you have to identify, there will be keywords like just exactly said chapter A. So we have to figure out keywords to see if they're talking about the left side, the right side, or both sides. So step 2, you prepare. So which is we're gonna do some calculation. Because here for this class, we are using StatQuant the most. So I will teach you, I will demonstrate StatQuant so that you can see it. You just type it in and we got the solutions. But for doing by hands, we have to compute a bit more. So in this section, in this PowerPoint, you will see that there's 2 methods, right? Compute by hands and doing StatQuant. I do both. So prepare, we do test statistics, which is we have to find a value T. And we check the conditions and assumptions. Actually, all the time when I give you an example or a question to do, all the time conditions are met. So you don't have to worry about that. You just need to do, which is to do the compute, to do the test statistics. So step 3, compute to compare. So for this step, you are using the formula to find T star and then find degree of freedom, because we're talking about the unknown variable, the unknown mean, the unknown standard deviations, which is S, which is a small s in the context. So we're using the t-test for this one. We're not using z-test, okay? And we're gonna compute a test statistics and compute the p-value. Lastly, we interpret that. What does it mean? So after you find a p-value, which is you check if it's smaller than the level of the significant alpha or bigger than the significant alpha, then we have to draw out a conclusion and interpret that. If we reject null hypothesis or not, okay? So that's the process. And you will see throughout all of this, step by step, and it's make things easier for us. So here is the formula. Here's just a formula, okay? Just look through this. So we are having what? Hypothesis test. What is it here? Claim about population mean. So for test statistic for one sample t-test, the reason they having t-test is like I said, they're giving us S. They're giving it S all the time, which is a sample standard deviations. Then you need to using t-test. If you wonder like what is t-test, what is z-test? Z-test is more common, okay? Because z-test, we are talking about they given us the population standard deviation, which is sigma. So that's easier for us to compute. But for t-test, we do just a small step extra, which is you have to find degree of freedom as well. Down here, let me annotate. If we compute by hands, then we need to find this by hands and compare with a table that I posted in the discussion board. But if we don't, then the StatQuant automatically do it for us. So you don't have to worry about that. So what you need to do is I recommend that you keep this in mind, this formula. They all the time given us X bar, which is the sample mean. They've given us the population mean, which is mu naught, and the standard error we have to compute by using this formula. Okay. S will be given, sample size will be given. So we got this formula, S divided by square root of n. We got a value, you plug it in back here. You plug back here, and then you compute t. That's it. And you got the t value. And the condition, like I said all the time, for this kind of example, all the time, this will be met. So no worry about that. And you don't have to check it frequently, because all the time I will give it to you the value bigger than 25. Okay, so the actual example is right here, which is you need to understand. Okay, so when we read this, you take note along, point out what is S, what is mu, what is X bar, what is N, and stuff like that. And all the things in here, the keywords you need to know as the right tail, left tail, the level of significance, which is you need to compare. So the level of significance is like the requirement. It's like the limit, right? So when you find a p-value, you will find the probability that are likely is make you to reject or not reject the alternate hypothesis. The null hypothesis, I'm sorry. All right. So in 2010, the mean years of experience among a nursing staff was 14.3 years. Okay, so what is it here? What is this sample mean or mu? Okay, so you're thinking about that one for a couple of seconds. You label it. So this value is our mu, right? Our nurse manager took a survey of a random sample. See that? Random sample. 35 nurses at the hospital. So this is the random sample, which is n. This is your n, the sample size. And found a sample mean. So they will give us sample mean, which is X bar. So this value is our X bar. Oh. X bar. Okay, with a standard deviations of 11.12 years. So X bar, so this should be S. Do we have evidence that, so here is our claim, right? Do we have evidence that the mean years of experience among the nursing staff at the hospital has increased? So this is our wondering. So here the keywords for you increasing, you thinking about greater than, right? Sometimes they put equal sign, but it's okay for greater than has increased. And use the level of significance of that value. So this is our alpha. So all of this value, when you analyze along, you have the value in your mind, and then it's helping you to type in correctly into StatQuant to run it. So you got a solution. Okay, so let's do next page. Let's see what happened. Okay, so next page, as you notice, the having step, right? So the first step, you have to state the hypothesis, which means you know hypothesis, which is at naught, colon, mu equal 14.3, right? So you have to include these values in when you're showing the steps. Okay, next step, next place that in step 1. HA, which is an alternate hypothesis, colon, mu. You remember the word has increased? So you're using greater than, which is when you're talking about the right size of the value, right? Okay, so we're having this. You type it, you write it in. So second step, you prepare, and you know that this satisfies. So now you're starting to compute that. So we are having the sample size, which is X bar, right? To find the t test, the t test, t statistics, you compute SE first, okay, by using the formula X bar divided by square root of n. So we plug it in. You're having the value 1.88. So you got 1.88. That's the error. So to compute the t statistics, you got a formula, right? That given. So what is 18.37 is? Let me go back. Go back to formula. Oh, so SE, I'm sorry, I said it wrong. It's S, right? Standard deviation divided by square root of n. So T is equal to X bar minus mu divided by SE. So that's how they compute by hands. To plug it in as the formula, you're having this value for T, okay? When you got the value for T, degree of freedom, which is n minus 1. 35 minus 1 give you 34. Right? That's how you are doing by hands. And to interpret the p-value, so to do the p-value, so what do? They run StatConst because we compute the degree of freedom is 34, and we compute 2.165 is the result of T, right? 2.16. You plug it in here to find the value for P. So in order to run this, I will run it, demonstrate for you. Okay. I'll go to StatCrunch. I remember this value. I go to stat. That's first step. You go to T stat, not T. Go to one sample with summary. Oh, this is how to run StatCrunch right away. So otherwise, maybe I'm using, because I'm using by hand for that step. So I'm hold on for this one. Go to stat. You go to calculator. You go to normal, standard, mean. Okay, hold on. It's just, let me go back a bit. Degree of freedom. Let's see. Go to stat, two stat, not one sample. Summary stat, let me see. Let me try this. the T calculators, you click standard. Degree of freedom that we got 35 minus 1 is 34. And this part is what? Let me see. 2.165. This is greater than, right? Because has increased. 2.165. Let's follow that and compute to see what happened. We have the solution as the right tail. This is T calculator, right? You go to stat, you go to T, you go calculator, and you go to T. And when I type it in, I have the p-value on the right side, which is the red part, is 0.0187. Let me go back to see. 0.0187. So we got this p-value. So when we're doing that, the p-value, you will compare this value with alpha. So for 0.05, you compare this to, okay, with 0.018. So which one is bigger? Alpha is bigger, right? So which is p-value is smaller. If p-value is smaller, we will reject the null hypothesis. We just reject the H naught, which is we not enough evidence that, you know, the stat will be increased, has increased. So evidence suggests that mean experience among the nursing staff has increased. We reject the null hypothesis. Let me go back to null hypothesis. What is it? We reject, which is we not agree. Okay, so let me go back. The null hypothesis that we have at the beginning. The null hypothesis, we reject this. This means we disagree with this. We reject this, which means after we compute, okay, we reject this. We not accept that. We do accept this one. We agree this one. We don't agree with this one. So that is the interpretation, which mean we agree that the story had talked about the nursing staff. So go back to nursing staff, right? Which is we agree that the mean years of experience amongst the nursing staff at the hospital has increased. We answer this question. We say yes, we do. That's how you run the compute by hands along with a bit StatCrunch. There's another method, but I'm not going to show you because I don't want you to like getting too many method. Do not stick with that and you might upset. So just follow this and follow my direction that I just demonstrate for you to see it. Okay, and you got the solution. So when you have everything, I would like you to take a picture, a screenshot, okay, copy and paste, and, you know, remember, interpret that. This question is a lot of points, so you have to do all the steps for me. Okay, so that is all that is done with compute by hands with a bit StatCrunch. So now to show you how to run StatCrunch. It's quicker, easier. I just need to, however, even though you run StatCrunch, you have to show me, let me see this all 4 steps, okay? So to run StatCrunch for this example, I go to StatCrunch. Let me close this. You go to stat and you go to T-stat. We're talking about one mean, one sample with summary. Now we'll type it in. Sample mean, what is it? Okay, we have sample mean is 18.37. I type in 18 0.37. Sample standard deviations, I'm having 11.12. Sample size, we have 35. We do hypothesis testing, okay? So if I want you to find confidence interval, then you click this box. But because in this case, we're doing hypothesis test, so you click that box, hypothesis test for mu. The null hypothesis we are having is mu is 14.4, if you remember. 14.3. And this we're talking about right tail. This not equal to, we're just talking about two tail. Now we're talking about right tail, which is greater than. Okay. What else that we need? We're not doing confidence interval, so skip that. We're not doing this, skip that. Optional graph, p-value plot. So I'm going to check this for now. Now let's compute. Okay. So when we're done compute, we are having 2 pages for this one. Let me magnify this. So let me check. Oh, so the step 1 is right there, right? So you hypothesize, you write hypothesis. The null hypothesis, right? This part. This is your step 1, correct? This is your step 1. Right? So you got that step 1, if you note that. And we are having step 2. Maybe it's in here. So since they compute it for us, then you can see sample mean, all of information, we got the standard error, everything, degree of freedom, they compute for us. They take 35 minus 1. They got t-stat for us, which is we compute by hand, like you noticed in previous demonstration. We are having 2.165, blah, blah, blah. Here, this is a t-stat, right? So you got this value, which is step 3, right? This is step 3. Step 2 is already, let me see already, the sample mean is greater than 25. That's met the requirement. I can see that in the p-value that you would compute. Got degree of freedom in here. After you compute, you got a p-value, which is what I'm looking for step 4. Right? Then you compare this p-value with alpha. That's step 4, right? Interpret that. So this p-value, you write, okay, step 4, then you got this smaller than alpha. Let me see, let me scroll down if we have second page. Let me see. Because I want to see the picture as well. Next page, here you are. Click next right down here and you see the picture. So here we have everything's here too, but I need that box and this picture. You can see the area, the right size. If we compare with the alpha would be around like up here, okay, around up here. So that is smaller than alpha. So that's met the that's good for us to accept the null hypothesis. So that's how you run StatQuant for one sample T. Okay. So this compute by hand, right? So you're using a calculator and go U to T, and then you got the value. And here is, that is done. So after you conclude this, we interpret that, what does it mean? Then you've done. If you're missing the steps, you were wrong. So right here to this slide, they given us the idea that sometimes they have the right tail, sometimes they have the left tail, sometimes they have both. Okay, so this is just like the formula for you to After we figured out from the keywords that I showed you, the keywords for nursing example, it has increased so that you know where is the one side, the right side or left, right? So another example that we are having for you. So right here, they're showing you how to do it by using StatQuants that I just run it. TI-84 for those people who are going using for face-to-face class, so you don't need to worry about that. And even for face-to-face, I still recommend using StatQuants to be quick. Okay, so another example, okay, hockey attendance. So right here, let's read over all of this to see what happened. Then you can practice doing on your own a bit. Or you can pause my lecture and do it by yourself and then check back. So in the 2010 season's average home attendance for NHL hockey games was 17,072. Suppose a sports statisticians took a random sample of 30 home hockey games during 2014 seasons and found a sample mean of 18,104 with a standard deviation is 1,203.5. Can we conclude that mean attendance at NHL games has changed since 2010 season? So the keywords that you can see has changed. The word has changed is meaning talking about two sides. They might have a different word like different, then there's two sides as well. Okay, so has changed is two sides. It's not clearly talking about decreasing or increasing, right? So this is two sides. So when you are take note out of the data, mean, sample mean, standard deviations, and stuff like that, you can run StatQuants. So here is compute by hands again, okay? And using StatQuants to do it. So we point out that value. So when run StatQuants, like just is similar to what I have done in a nursing example. You just type it in, figure out sample mean, figure out sample standard deviation, sample size, and click hypothesis test for that. So you see that here is not equal to because the word has changed. And you click that and you got the value all here for you. P-value, got all the step here. P-value here is look like smaller than 5%, right? So then what do we have to do? We will reject the null hypothesis and we do accept the alternate hypothesis. That's the interpretation. Okay, compute, compare, test statistic, we have this value. So right here, the conclusion, the interpretation is that we will reject the null hypothesis. It means, yes, the attendance hockey has changed, which is we do accept the alternate hypothesis. Okay, that is 9.4. So practice over and over again, slowly take note on it, and you will be fine. 9.5, we're talking about two population means now. We're comparing two groups, right? So we will conduct a hypothesis test and construct a confidence intervals. So we do two things now. We do finding confidence interval and figured out how to conduct a hypothesis test for two means, two population means. So what do we do? So let's read a bit about this one. When comparing two populations, it's important to note whether the data are two independent samples or a pair, which is dependent sample. So how do we figure out pair or independent? Independent is very separate, right? Very like not related to each other. So pairs like they depend, like for example, like we're talking about this group in this year and we're talking about this group again in another year. That's a pair, that's dependent. So let me see, each observation in one group is couple or pair with one particular observation in other group. So example, before and after comparisons, right? Like I said, like different years maybe. Related objects or people. We talk about twin, sibling, or spouses. So here, check this out. An example so that you can identify this is dependent or independence. People chosen in a random sample are asked how many minutes they spend reading and how many minutes they spend exercising during a certain days. They are comparing, right? Comparing one person do two things in a day. Researchers wanted to know how different the mean amount of time were for each activity. So when we're reading about this, the sample are dependent or pair. The study was based on one sample of people who were measured twice, reading and exercise. How about this one? This is the same example for independence. A sample of men and women each had their hearing tested. Researcher wanted to know whether typically men and women differ in their hearing ability. Is this a dependent or independent sample? And this is obviously independent because it's talking about two persons separately. All right, so let's do an example. Let's see. Again, the requirement is just similar, but the different things is like we got two population mean, two sample mean, two standard deviations. Everything is two sample size. Okay, so here's a formula, general structure. We got estimate plus and minus margin of error. This is the compute by hand. This is how you compute by hands. So the estimate of difference, you plus and minus t star, which is the t value that you need to compute. Okay, the SE you already know will be the general formula for one sample is S divided by square root of n, right? But this time you got S1 minus S2 or something divided by square root of N1 minus N2. So it's now combining two sample mean right here, plus, they're plus, not minus. And they do the square things here. So when we compute by hands, then you using this formula, because I don't remember formula exactly. So here it is, SE, estimate of the differences between two group equal to square root of S1 squared divided by N1 plus S2 squared divided by N2, so everything squared, square root of that. So if you got two sample mean, then you take as sample mean x1 minus sample mean of x2. You plus and minus, the plus and minus here talking about you find the interval. Okay, plus and minus, you find the interval, which is for the minus side, you finding the lower interval, lower value, and plus side, you find the upper value. So here relate to confidence interval. Right, just let you know ahead. I know the formula is kind of long. Hopefully it's not confused. You just write it down so that you can look back, because I myself cannot remember all of it. So the T star will be based on the approximate the T distribution with the degree of freedom at a smaller of that. So in order to find T star, actually, StatQuant will do it for us. You don't have to worry about that. Okay. So that's just like the outline for you, but you don't read this. So let's do the actual example to see what happened. Okay. When you do an actual example, it's more easier for you to understand what's going on. They're talking about units. Example about unit. A college randomly survey day students and evening students to determine the number of units students were enrolled in. The data is shown in a table below. They give it to us. So like you too. Sometimes they don't give you the table. You have to, like point out n, 1 and 2, x1, x bar 1, x bar 2, s1, s2. You have to figure it out. So the question they want to asking us is, use the data in this table to find a 95% confidence interval. Okay, for the differences in the mean difference in number of units for the two groups. So based on our confidence interval, is there a difference in mean number of units taken by day and evening student at the college? So now keywords, you see that the word is there a difference in mean. So that would be not equal to, right? If we're talking about hypothesis. So now obviously they're asking us to find a confidence interval, find confidence interval. Okay, so we have to find that confidence interval first to see what happened and then compare back. So we have all of this value. Okay, remember that. You can take a screenshot of this value so that you can type in the StatCrunch. So now we're going to do the following. We go to follow this direction. Go to stat, tstat, to sample. Remember 9.4, I click stat, tstat, and I click one sample with summary, right? So this time is two sample with summary. So they have all the value here for you. You just type it in, following this. See that? We have sample 1, we have sample mean 1, standard deviation sample 1, sample size 1. Sample 2, we have sample mean number 2, sample standard deviation number 2, which is 3.7, sample size number 2, which is 68, and so on. You type it in like that exactly. And then here, because they're talking about confidence interval, you click the second box, confidence interval for N1 minus N2. Okay, and level of significance is 95. Sometimes they're asking for 99 or different value, you type different value in here. If they're asking for 99, then you type in 0.99. Okay, you can change the confidence, the level of the confidence interval. So that when you're done, because here they're talking about confidence interval, then you choose that one. But if they're asking for the hypothesis test, then what you're going to do, you click on the first box, right? You click on the first box. Click on that box. And the case here is not equal to. You click not equal to. Okay, 0 stay. Then you click compute. But this time they're asking for confidence interval first. So let's check that out. After you're done so, compute. When you compute, you got this window pop up. So here will be the step. Okay, they're giving us all the information. We got sample of difference. They did the algebra for you. Standard error, they did it for you. If you remember this formula is kind of long, right? Degree of freedom, they did it for us. They do the n minus 1, n minus 2, something like that. They multiply. That's computed by hands, but here they did it for us. So the conclusion is here. You got a lower limit and upper limit. So when you do interval, you put inside the parentheses like that, and you put a comma. You got this value first, 1.65. You round to the 100th place, which is 1.66. And then you got the next value is 3.94. as the conclusion, confidence interval. Okay, so if the question asking you to interpret, what does it mean? Then you're going to say, so there are 95% confidence interval, and then you read the story, will accept from here to here. The mean will be between these two values. So that is how you are running StatQuant and having the value. You see that the solution, what they do, they put inside the interval is like that, and you do the same thing. I want to see all of this on your test. If you run StatQuant, I want to see all of this, okay? So here is the interpretation. Am I asking you to interpret that? What does it mean for that interval? Then you're gonna say like what? You're gonna say they students enroll on average in more, in your own words. You don't have to be exactly like this. In more units than evening student at the college level, at this college, the difference in the mean number of units enrolled is estimated between 1.66 and 3.94. Okay. This sentence is just from the prompt, right? Just from the question that they're asking you, that you just reply. So here for using TI-84, just follow this. If you want to use TI-84, and you're done. So now we do go on to the second example, sample home prices in Albuquerque Creek. The data of selling price, we have the following table, and they want us to construct 95% confidence interval again. Okay, and they're asking, is there a difference in home prices? That is how you interpret, you are concluding it, write a conclusion. So here they having everything for us. What you do again is just follow like example 1. You just type it in. You go to this step, right? Type it in, and you got a value for lower limit and upper limit. The whole box here, you have to screenshot and copy and paste for me. And doing interpretation will be what? Since the interval contains 0, there is no significant difference in the average home prices between the two areas. Right. For hypothesis testing, like I said, just exactly the same step, but you just change the box and you're done. But make sure you figure out is the right tail or left tail as well, right? For example, for this one, if they're talking about hypothesis test, go back to the home. Is there a difference in home prices? You see the word difference? This mean two tails. This is not equal to. And you just click on the box, the first box here. Click here instead of the confidence interval. Click that box and you put not equal to, then you're done. Very simple when we're using StatQuant. For this two example, you have to practice over and over again so that you get used to it. Even only two example, but it's like showing you everything. Right? Step 1, step 2, and so on. For it looked like compute by hand, it looked like a lot. You see that? But when we're using StatQuant, it's very short. You don't have to compute a lot of steps, you don't have to spend a lot of time. You just type it in and you're good. Okay, so let's look back the example 1, units, right? See that? The box is the same thing. So now follow this. You got step 1, you got null hypothesis and alternate hypothesis. See not equal to? Just the way that they're writing it, you see that because I show you the keywords, that's why I know it's not equal to, right? And then you keep doing that using StatQuant. And what happened? Using StatQuant, you got stat, you go to T-stat, choose sample with summary, right? Like this. Right. Let me demonstrate one more time for you. You go to StatQuant, right? You go to stat, go to T-stat, go to choose sample, because we're talking about choose sample with summary. You type it in, sample 1, sample 2, which is the box already given. You type it in, type it in, type it in. You click hypothesis test, you see? Not equal to, you click here. And you click compute, you're done. Right? So let me try that for you. I take the screenshot for my data. I go to StatQuant. I enter in 8.7. This is example for unit student taking on day and night, right? And 3.1, which is the sample standard deviations. Sample size is 72. Okay, now sample 2. We got 5.9. Sample mean, sample standard deviation for this is 3.7. Sample size for this is 68. Hypothesis test, you put that, leave it there, but here is what important. Greater than, less than, or not equal to, you click not equal to. Right. Then now you've done everything. They will compute everything for us. SET, p-value, you click compute. You have this. Big. I want you to graph as well. Then make sure you click the bottom will be have the I forgot, have the graph box or something. If I don't say graph, then you don't just ignore it. Then you just run this. We got a step 1, mu minus mu1, no hypothesis, alternate hypothesis. That's the step you need to show me. We got standard deviations, standard error 0.5786. Degree of freedom, they compute for us. T-stat, they got that. P-value is less than 0.0001. So this is smaller than alpha, which is 5%. So again, for this happen, you have to conclude you will reject the null hypothesis. All right, exactly the same. So the interpretation will be there is, yes, we accept the alternate hypothesis, right? So we say there is a difference in mean units between day and night student at this college. Because they're asking, is there, right? Is there a difference in mean unit between days and night of the student? We say, yes, there is. And this is for using TI-84. So this is about a home, right? Example 2, like I said, instead of you click on confidence interval, you click on hypothesis, then you're done. Like just demonstrate for you for example 1. So this is how they do. They just type it in everything. They got a value, they got p-value is 0.0526. Compared with this one, 0.0526 compared with 0.05. This p-value is bigger, which is you have to conclude that you will accept the null hypothesis, which is H naught, and you do not follow, you do not agree with the alternate hypothesis, which is HA. Right? That is what it means. You see the interpretation. So because the p-value is 0.0526 is not less than the significant level, which is 0.05, we cannot reject the null hypothesis, which is we will agree with the null hypothesis, H naught. So we cannot conclude that the process in N.E. neighborhood differ from the rest of the city. That's the conclusion, the interpretation. So the interpretation is important, so I will let you do it too. Okay. So right here, they give us conclusion or something, but no worry about this one. You just need how to understand, interpret that, and run StatCrunch with that, and understand the process, the steps, then you'll be okay. Okay. So for this example, they said they're talking about what? Suppose fourth grade children are exposed to a reading intervention program designed to improve score on the reading assessment. Children were given a pre-test and post-test before and after the reading intervention, and the score are shown in the table below. I assume that all the conditions needed to construct a confidence interval are met. So they want us to construct a 95% confidence interval for the mean difference in reading score after participating in the program. Based on your confidence interval, do you believe the reading program is effective? So it looks like right here, they're not giving us the data yet, maybe in the table below. There you go, pre and post. So right here, they're giving us a lot of data for pre and post, for reading intervention, the differences they compute there. So what do they do? So the differences are pre minus post. So we are using technology to create 95% confidence interval using the difference data. So you follow this. So you type it in, right? You type it in the data, and we are using one sample T. So one sample T, let me demonstrate for you. We have pre, post, difference. We're going to use different column, okay? And then we're going to click on confidence interval for that one. Then we're going to have the value. Okay, so let me have the screenshot for this data. Then I will demonstrate for you to see it. So this one, we're talking about dependence events. So StatCrunch. I don't have to type in pre or post. I can type in the column only for -2 for the difference. It should be a bit quicker. We got 0, -2, -1, -6, -4, -1, -2, 0, 1, 0. So how many? Total is 11. Let me count. Yes, that's correct. So next, you're going to go to Stat, Calculator, one sample T. Calculator, let me try this. What's that? That T is that one sample. Sample summary and sample mean. Okay. Hypothesis test. So here we're talking about that. So wait for me a minute. This is one sample T summary. Let me go back here. Follow instruction. This is one sample T. Okay. Confidence interval. Make hypothesis. It looks like I have to type all out, huh? I need to type all out. Let's see. Let me go down here a bit to see if they need to type all out. Okay, they're not showing, so maybe I have to type all out. Let me type all out. It's take time, so let's wait for me a minute. So I will use that table. So I'm gonna move this table. I'm gonna use this for different, type in the word different. This I can type in P. This is post. And P10, 14, 21, 18, 15, 16, 18, 19, 20, 25, 16. Okay, have a post. So you help me type it in. You just follow it. Just do the same step as I do along if you want to follow. Got 14, 23. I'm not gonna go give you this many value. 23, 19, 21, 20, 19, 21. Wait, I'm not enter wrong. 24 and then 16. Close this one. Do stat, T stat, and this is one sample with summary. Let me see, they don't give us the not, how about with not with summary. T stat one sample with data. Okay, one sample with data, not with summary, because we are having like 3 columns here. So what I'm going to do is I'm going to follow this. I'm going to choose difference. Click different. Go to hypothesis test. And here we're talking about, let me see, go back here. We're talking about the confidence interval. 95, right? We don't click hypothesis. We click on confidence interval because they're asking for confidence interval at 95 level. So what if I want 99? You click, you type in 99, okay? If I want 90, you type in 90. So now this question asking for 95, you type 95. And I think that's all. Let's compute. So when we compute, we are having this negative value for lower limit and upper limit. Let me check with solution with this part. The textbook, they have what? They have lower limit is negative 2.9, upper limit is negative 0.18. Let me check with mine. Negative 2.9, negative 0.18, okay. So we are having like that. Okay. Similar. No graphing for confidence interval. So let me see if I can graph. Let me see. Go to stat again. You go to T stat. You go to one sample. You go with data. You click difference. You click confidence interval. Let me see if they have picture. They don't. They not showing us the graph. Okay, so there's no choice. Okay. So let me make a different example. I would like to have 90%. Let's see what happened. All right. Make 90% confidence interval. Click compute. You see what the value will be different, right? Will be a bit narrower. which is negative 2.648 and all the way to negative 0.44, which is a smaller interval compared to 95%. See that? So that if I change that, then you want to do like that. So let me see. Go back to the example. Let me see if they did compute the differences already, or we have to do on your own. Let me check. Or they did compute for you. So if they did compute, there's example that they already compute all of this already. Then I want to try if I don't using pre or post, but I'm going to use different columns. So what happened? So let me remove. So here is, I'm pretending you all follow all of this already. You have to type in all, right? So I want to make a test. I want to make like, if I remove this column, let's see. If I delete this column, I want to see if they will give us the same example or not. Column, delete. Look like we should not. Highlight it. I highlight that and then I click clear. Let me see if I'm using, now I erase all that two box and I only leave the different box. I go to stat, I go to tstat, I go to one sample with data difference. I want to try it because I haven't tried this one before to see if they got the same value with this data. Let me see. Okay. Look like, let me compare with the textbook. They're having the same value or not. Negative 2.9 with negative 0.1a. Negative 2.9, negative 0.1a. Okay, 10. Let me see sample mean. They got the same or not. Okay. Standard deviation, they got the same too. Okay, that's look like we can do it. So to save your time, you can only click on the, you can type in the StatQuant, only the different box, right? Don't type in pre or post, with like you can save a bit time, more time, right? Like I just make a test on it. So you just can type in the difference box only. Then you run StatQuant quicker, save your time. Yes, we can do that. Okay, so here interpretation. The 95% confidence interval for the difference between the pre-test and post-test score is that interval that we found in StatQuant. So since the confidence interval does not include 0, there is a significant difference in the mean pre and post-test score. However, the difference is not large in size, which is 0.19 and 2.9 points. Since the difference were for pre-test minus the post-test having negative value, means the post-test score was greater than the pre-test score. Agree? So there was improvement after reading intervention. It's a long interpretation. That is what I want when you are doing this type of pair sample. We call pair sample because they are dependents. Okay. Hypothesis test, you do the same thing. We are having the, the not equal to. So look back the example if there is key for us to point out if we are doing the not equal to part things. Here they talked about confidence interval. Okay, so here there's no word based on confidence interval. Do you believe that? Okay, so maybe let's see if they change the story a bit. Check this out. So using the reading and pre-post test data to conduct hypothesis tests to see if there was a difference. So here are the keywords. There was a difference in mean of pre-post test after reading of that. See that? So that's the difference. So that's why we got not equal to. So they write the bottom part instead of they want us to find the confidence interval. They will write this part. Replace that part as part A, part B. I might write the question like that as well. I might write as part A is find the confidence interval. Part B is conduct a hypothesis test like this. And I might switch the story like that, and you will do 2 steps and then show me, okay? Like I said, you to save your time, you don't have to type in pre or post. You just type in the difference and then follow the step like that and figure it out. Instead of click confidence interval, you click on hypothesis test for me like this, right here. Right here. Right? If I'm asking for hypothesis test, then here already show you all 5 steps, except the interpretation for this, then you have to write separately. So after you run and everything, you got the p-value is 0.0294, which is smaller than 0.05, then you will reject the null hypothesis, right? So this step is compute per Helms, except the interpret. You say, yes, there is a difference in mean pre and post test score, because that is the alternate statement, right? You answer yes for HA. That's all for session 9.5. It's very interesting. It looks hard, but it's not hard when we're using StatQuant, right? So what you need to do is for this chapter is practice over and over running StatQuant for confidence interval and hypothesis testing, and you're done. Okay, class, thank you very much. If you have questions, please join the Zoom, ask me a question, or ask me in class. Thank you. We're done with the course. So this is all we're done with the course, okay?